Variation of ionization energy in the periodic table. Ionization energy it provides another example of understanding periodicity among the elements. The ionization energy of elements S and P blocks are given in table 10. Electron affinity. Just as energy is required to remove the electron from matter, energy is released when the electron is added to a neutral atom. This is called electronic affinity. Thus, the amount of energy released when the electron acid is added to isolate gaseous atom is called electronic affinity. As the definition implies, the magnitude of electron affinity measures the ability of an atom to hold an additional electron. If an atom has more tendency to accept the electron, large energy will be released consequently. Electron affinity will be high. On the other hand, if an atom has less electron affinity can be positive or negative. When energy is released during the addition of the electron to the atom, the electronic affinity is taken to be positive. Electronic affinities are expressed in kilojoule mole inverse. Factors on which electronic affinity depends. There are many factors which are govern the electronic affinity, but the following are some important factors on which it is mostly depends. Number one, nuclear charge. The electronic affinity increases as nuclear charge decreases. This is due to greater attraction for the incoming electron if nuclear charge is high. Number two, size of atom. With the increasing in size of atom, the distance between the nucleus and the incoming electron increases and it results in less attraction. Consequently, the electron affinity will decrease. Electronic configuration. The element having stable electronic configuration of half and completely filled valence subshells show very small tendency to keep additional electrons, and thus electronic affinities are low or almost zero in certain cases. Periodic trends. Due to lack of sufficient data, the changing trends in electronic affinities on moving along the periodic tables are less defined than those of ionization energies. However, it is been observed that the electronic affinity in general decreases from left to right in period and decreases from top to bottom in group. These variations are discussed below. Number A. Variation down a group. On moving down a group, the atomic size and nuclear charge decreases increases, but the effect of increasing in atomic size is much more pronounced than the nuclear charge, and thus the addition electron feels less attraction by the large atom. Consequently, electron affinity decreases. This is clear from decrease of electron affinity is going from chlorine to bromine into iodine. Variation along period. Moving across a period, the size of atom decreases and nuclear charge increases. Both these factors result into greater attraction of incoming electron. Successive electronic affinities like ionization energies and the second and higher electronic affinities are also possible. However, the second electron is added negatively charged ion in the addition is opposed the repulsions. The energy has to split to the 4 second electron has shown below the oxygen atoms. In other words, the second and higher electronic affinities would have negative values from the first electronic affinity in which energy released is taken as positive. For example, the first and second electronic affinities of O and S are oxygen EA1 140.9 kilojoule, EA2 minus 770 kilojoule, sulfur 200.7 kilojoule minus 333 kilojoule. Electronegativity. When a covalent bond is formed between two homonuclear atoms, The shared pair of the covalent bond lies exactly midway between nuclei of the two atoms because both the atoms may have same attraction of these electrons. For example, eight molecules has S2Cl2 F2. The electron pair remains exactly at half distance between two nuclei. However, in the case of covalent bond between dissimilar atoms, heteronuclear molecules, the electron pair may be closer to one another. This is due to fact the different atoms have different tendencies to attract the bonded pair of electrons towards itself. The tendency of atom attract the shared electron pair in a molecule towards itself is called electronegativity. Number one, Pauling scale of electronegativity. In 1992, different atoms have different tendency to attract the bonding electron pair towards themselves. Greater the ability of an atom to attract electrons in bond, larger the value of its electronegativity. It must be remembered that unlike the other atomic properties such as ionization energy and electron affinity, which are related to individual gaseous atoms, the electronegativity is related to the atom in their bonded state. There is no direct method of measuring electronegativity. However, various attempts have been made to derive a scale of electronegativity for the elements. Some of these are discussed below. Number one, Pauling scale of electronegativity. In 1932, Linus Pauling was first to propose the scale of electronegativity. He proposed that the scale based on the bond energies in heteronuclear bonds. He suggested that if two atoms A and B had the same electronegativity values, the bond energy of A to B bond would be equal to the geometric mean of the bond energies AA and BB bonds. For example, bond energy of AB molecule is written as EAB is equal to EAA into EBB multiplied by half. Disadvantages of Pauling scale of electronegativity. The main disadvantages of Pauling scale is that the bond energies are not known as good of good accuracy for many elements. However, the values are relatively values. Number two, Mulliken concepts of electronegativity. Mulliken in 1934 suggested that the tendency of an atom complete for shared four electrons in a bond should be the average of ionization energy IE and electron affinity EA. Thus, according to Mulliken, electronegativity of atom is equal to IE plus EA divided by 2, where both IE and EA are given positive values. The physical picture of Mulliken concept is reasonable because the tendency of one atom to attract a shared pair of a bond should be average of the tendency of atom to hold its own electron and tendency to attract the additional electron. The Mulliken values expressed in EV have been found to be about 2.8 times larger as Pauling's values. Therefore, these values are divided by 2 by 8 to get the Pauling's values, that is x Pauling is equal to x Mulliken divided by 2.8. Disadvantages. Number 1. Electronic affinity values of only a few elements are known. Number 2. IE and EA values change with vacant state of element. Number 3. The concept is based on the electronic force of attraction between the electronic and its nucleus. The force of attraction is taken as the measure of electronegativity. The force of attraction between nucleus of the atom is valence electron governed by Coulomb's law as given as force is equal to Z multiplied by E divided by R square, where E is equal to charge of the electron, Z is equal to effective nuclear charge and are mean distance from the nucleus.